Hi, Jeff Nepper, Managing Partner at Flow Software. Thank you so much for joining me for a quick dive into how we can build better analytic frameworks. So, what is Flow Software? Simply put, it's an analytics framework that's designed to help you define, transform, and then openly share the information that your organization needs to make better decisions. So if we're going to explore analytics, perhaps we should agree on a definition. Analytics is simply the practice of using data to make informed or better decisions. And when we think of analytics, there's 4 different categories that we should consider. First is descriptive. Descriptive analytics help us describe what has happened. Typically, we might look at a historian, study a trend, and get a sense of what has happened in the past hour or day. The second type of analytics is diagnostic. Diagnostic is simply answering the question, why did that happen? Here we might look at a secondary data source or a secondary tag and try to create some type of causation or correlation to answer this question. Third, predictive analytics. There's a lot of buzz around predictive analytics, and you may have a definition of predictive analytics in your head that includes a special type of black box that a lot of data gets crunched, and then it tells you if you're going to have a high likelihood of downtime or machine failure. Or your idea of predictive analytics could simply be linear regression or exponential regression using things like runtime and historical data. Often when we think of predictive analytics, what we're really thinking of is the 4th category, prescriptive analytics. And prescriptive analytics seeks to answer the question, what should be done? Consider this. Predictive tells us if something is likely to occur. Prescriptive seeks to tell us the best opportunity or the best action that we could take in order to achieve our organizational goals. So an example of this, predictive might tell me that I'm 87% likely to fail on a piece of equipment in 7 days, but prescriptive would be able to look ahead, see that we have planned downtime in 11 days, make suggestions around reducing the run rate to reduce the likelihood of that piece of equipment failing prior to the scheduled downtime, and even perhaps check to see if we have parts availability on what is most likely causing the problem on our equipment. We are a long way from achieving prescriptive. Most organizations aren't even doing predictive at any type of macro level as of yet. So, what is the right way to approach analytics? We believe that starting with a firm foundation of descriptive, diagnostic, focused analytics is the right framework so that when you're ready, you'll be able to take advantage of the predictive and prescriptive analytics available to you. In fact, we're not alone in this. Recent industry studies have shown that in most organizations, 80% of the current value can be found looking into descriptive and diagnostic analytics. That means right now, inside of your operation, there's likely a lot of low-hanging fruit that we should be able to help turn into better decisions and a fast ROI, while enabling future predictive and prescriptive analytics. Think through your organization for a second. What types of systems do you have in place? Are you collecting a lot of data? Are you currently putting that data into other databases? Do you have applications that are currently or that you're working with, maybe integrators, in order to try to find insights and better next actions inside of your process? Well, why do we have all of these systems? What is it that we're actually after? Ultimately, we're doing all of this so that we can easily get to information that's ready for us to use, that we can trust and rely on to make better decisions. And historically, the process of doing this has been pretty straightforward. We'll choose something like a BI tool and we'll connect a historian and an MES solution to it. We'll do some type of data crunching inside of that application, come out with a couple of KPIs that we can act on, and then publish that maybe through email or through a messaging app in order to put it in front of the right decision makers. And if we see success in that and an ROI, which we should, then we're ready to move on and do the same thing in another application. In this case, let's take a look at Seek. Seek is an analytics tool that we can look and do some advanced pattern recognition, and we would grab data out of the historian and SCADA and MES, and that way we can do not just descriptive but diagnostic analytics. We can look for causation between multiple data sources for things like downtime or perhaps low performance on our equipment. And again, within Seek, I'm going to bring in multiple data sources. I'm going to try to mine that data, cleanse that data, find correlation in that data, and then have some type of an output. And we will keep doing this over and over inside of our organization. In fact, if you think about all of the different integration work that you've done to tie your systems together, you might consider this small little map as being on the lighter side of that work. So while we're doing this, we have to recognize that there's problems that we're going to encounter along the way. First, a lack of data standardization. So we keep doing this work over in the applications to try to create standardization so that we can look at multiple data points and multiple data sources and pull insights out of that. Frankly, it's a lot of work. If you have ever had to write a SQL query to pull a lot of data from a SQL database and then try to match that to time series data, you know firsthand the problems that you encounter in doing that. And this is precisely the problem, is because we have this lack of data standardization, we're actually beginning to create more problems for ourselves. And the problems that we're creating for ourselves is all of this work, all of this standardization, all of this scripting and coding, it has to be created and live somewhere. And as you likely know and have experienced, the more custom code and script that we write, the less scalable solutions become. Another big problem, this work, it keeps getting orphaned over in the applications that we're using. So that means if I do work in a BI tool, if I do work in Seek, I don't get to pull that work out of those products and go reuse it when I want to try machine learning or when I want to experiment inside of Azure or AWS. So I orphan the work's not scalable, and I continue to do all of this custom integration just to try to make my databases a bit more standardized and normalized. There's got to be a better way to do it, right? And that's exactly what we're looking to do, to show companies how they can perform analytics and build an analytic framework that scales. So what's missing in this diagram? Well, instead of all of these connections back and forth, what if we followed more of a hub approach? Building an information hub is the easiest way to standardize data, contextualize data sources, work on building out information that can be shared, not just to people, but to systems, and not having to try to manage custom code and scripting, which would hold us back from scaling operations. And that's exactly the problem that Flow looks to solve. If you are just getting started in your analytics journey, or if you've been working at this for years, this analytics framework will help enable everything that you want to do today, tomorrow, and into the future. Join me in our next video as we look at the 3 necessary steps to enable an analytics information hub.